also we have a guest here, Eric. He's from Microsoft. Actually, I think it's a good time for us to share among how the learning and teaching to be done. So therefore, I put up cameras here. Don't feel hesitant, feel trouble with that. Thank you, Sunny. Would you please elaborate in English, please? Now, when you are turning in, starting the computer, so I'm going to ask some questions, what you learned last time. Before I ask a question, can anyone tell me what you learned last time then? Very good. Some hardware. Thank you.
Things about CPU, how to
Computer things.
So one by one, I need to elaborate a bit. Just a moment, please. I need to update the plan.
The content is that CPU.
So today we'll focus something what we left out. So now, Owen said we learned something hardware, correct?
yeah.
What else?
Something about CPU.
Something about CPU.
Yeah.
What
And the ROM and RAM.
ROM and RAM.
What is it?
ROM and RAM.
ROM and RAM. Very good. Does anyone know the full name of the RAM?
RAM係咩相memory？
Put up your hand next time, Catherine. Thank you.
啲快而準㗎嘛。
And what's ROM then?
Read only memory.
Again, please put up your
我第
hand.
一個女啊。
Donna?
我最後一個女。
Okay, now, if you know what's the RAM and ROM, what is the differences between them then?
ROM 係
Yes, RAM can only store when electricity is plugged in and when the
Okay, stop. Okay, Stanley, what's wrong then? You said you put up your hand.
ROM 係
Could you elaborate in English for both, please?
ROM can this memory can 點講
internal storage.
So what's wrong? Compared to RAM then?
comparing to RAM
Yes, Yo-Yo,
is
I'll back to you. Will not be gone.
Permanent information。
Whenever, even though when it's cut off.
power
Power, very good. So the ROM, meaning we store something there, even though when the power is off, all the data remain the same. Okay? So can you tell me what kind of program would be very appropriate to store in the ROM? Donna? What program? Store program. Can you give me an example of store program?
Rice cooker。
rice cooker.
Okay. So rice cooker stored in the ROM?
ROM store in the rice cooker。
Okay, a store program. You didn't. So what? Okay. Can you elaborate more? So what would be appropriate to store inside ROM? Can you give me an example other than rice cooker that you use it, say you carry around you all the time? What kind of program? Okay, can you elaborate more about mobile phone? How you store program in there?
即係嗰啲 setting。
Very good. What kind of setting there?
The background, privacy, whatever.
RAM
No. Yes.
bootloader.
The loader booting.
Yes.
Okay. The bootloader. What's the bootloader then?
當你撳個掣，when you press the button,
Yes. When
and
you
it
press the
will
button.
start running, and
Starting
you
running.
read the bootloader from the ROM, so that you can start.
Okay, very good. So we can start the program section. Hasn't mentioned, and Sunny hasn't mentioned anything yet. Want to add something there? Understand. You add something there. About wrong.
It's wrong.
It's not wrong. Wrong.
Storage device.
What is that?
Storage device.
Storage device. Okay.
Like a floppy disk.
Okay, last time what we left out, we watched a video. Would you please have the connection on now? And put it, allow update. Allow update.
For how long?
係咪有問題？唉，真係〜
So I update a bit of thing for you today.
觀音添。
Is underneath the computer system.
雖然我呢度喺新西啦。
哇！
Stanley, stop talking, thank you. So update your system, please.
應該俾人鏟晒啲嘢。
I create something for you about a microchip. So how a microchip would look like.
內
So for some computer, because you changed the computer, so what you left out last time, you still have to download it all over again. Take some time, okay? You already have it. Very good.
Wait, microchip 係 what's inside a look inside 呢個係 how microchips are made.
Now we're going to take a look inside a microchip.
Okay.
Please have a view on that, please.
Inside where?
Under CPU,
冇海綿添。
level number 2,
Have a look inside.
a look inside microchips. It will take only 2 minutes, just a glance of it.
300人而家都
Do
到
I
而家
have
都
to
未。
have to
Okay, how about we all watch it together then?
How about
computer system CPU 啊，
Okay? Only,
真係唔使聽完你冇講嘢。
okay, let's play this.
都係呢幾
咩嚟啊 ？CPU 啊
It's level 2 microchips.
What is inside a microchip?
Correct. A look inside microchips.
終於得
我哋而家睇緊啲嘢。
like
See how small the chips will be.
撈都未開始撈喎。
Okay, when you're loading, your computer is already reviewed outside.
喂，shit，
You can see how tiny each part. I'm going to show you later, please. Okay, good. You can look at this. So very tiny, magnified, the high magnification. So all the circuitry, 4,400X. So all this circuitry can fill us with gates, what we mentioned last time, to computation. Okay? We'll stop here, and if you want to go through it, you can do it at home. Second thing, then just Sunny asked, so how this microchips be made?
how microchips?
So this is an 8-minute video.
You may not realize it, but we're surrounded by arguably the greatest, most revolutionary invention of the last 50 years. It's in TVs, stereos, watches, cars, phones, traffic lights, and pretty well every appliance in your kitchen.
So
In fact, these days, if a device uses electricity, it probably uses one. The tiny gizmo in question is, of course, the silicon chip. Making these extraordinary miniature electronic brains is one of the most complex manufacturing tasks ever attempted. So how do they do it? Texas, USA. Home to big stuff. Big cows, big boots, big hats, big moustaches. But Texas is also the birthplace of a miniaturized miracle, the silicon chip. And here in Sherman, 30 kilometers north of Dallas, is the
Anyone remember
MEMC
how that thing
fabrication
called?
facility.
The circular stuff? What that called?
Here in this strange,
Circular
futuristic-looking plant, they produce silicon wafers, which are the basis for all modern
I'll ask
microchips.
this question again. The circular thing, what they call?
Silicon has special properties because it's what's called a semiconductor.
Silicon.
That means, depending on how it's treated, silicon can either conduct or block the flow of electricity. It's this property that makes it perfect for supporting the millions of tiny transistors necessary for a modern computer chip. The trouble is, because these transistors are so incredibly small, the silicon base on which they rest needs to be absolutely perfect. It took decades to discover a way to produce silicon with a perfect monocrystalline structure. They begin with raw polysilicon, or poly, and heat it to 1420 degrees Celsius inside a special sealed furnace, which has been purged with argon gas to eliminate any air. The resulting lake of molten silicon is then spun in a crucible, and a silicon seed crystal, roughly the size and shape of a pencil, is lowered into it while spinning in the opposite direction. As the molten polysilicon is allowed to cool, the seed crystal is slowly withdrawn at around 1.5 millimeters a minute. The result is a single silicon crystal weighing around 200 kilos and with a diameter of around 200 millimeters. The crystal is so strong, its entire weight can be supported by a single thread just 3 millimeters across. But it is brittle, and it must now be cut down to size without shattering. So after testing with chemicals and X-rays to check its purity and molecular orientation, it's fed to a silicon salami slicer. This 10-ton wire saw uses a fast-moving web of ultra-thin wire to produce wafers of silicon that are just 2/3 of a millimeter thick and 99.99999999% pure. But once cut, there are microscopic marks left on the wafer's surface. So it's time for a buff-up using a process called lapping. But even after a twirl in this high-powered polisher, they're still not smooth enough. So they're then given yet another buff using a chemical process. The result is wafers of silicon with a surface roughness of less than 0.1 billion billionths of a meter. Buffed to a sheen, they're now ready for etching with the circuit design. Packing millions of transistors onto these tiny wafers is the job of chip manufacturers like Texas Instruments. Back in 1958, the inventor of the integrated circuit, Jack Kilby, managed to squeeze a single transistor onto his design. These days, the latest generation use almost 1 billion, and according to Moore's law, that number doubles every 2 years. But of course, the more they try and pack into the design, the smaller each transistor needs to get.
There are over 250 million transistors in this design. Someone has to shrink them down to this.
Working at this microscopic scale exposes the chip makers to a major problem. When a transistor is only 1/10,000th of a millimeter across, the smallest particle of dust is enough to cause an electronic train wreck. So before staff like Dane Bailey set to work in the fab, it's on with the bunny suit.
Wafer fab stands for wafer fabrication. We build the chips here. We start with the bare silicon wafer. We run through a multitude of different processing steps. For our general product that we make here, a DSP, typically takes on the order of about 1,500 individual processing steps from start to finish.
With an area of just under 18,000 square meters, the fab is a Class 1 clean room. Thanks to 12,000 tons of air conditioning equipment, the air is 1,000 times cleaner than a hospital operating theatre.
There's actually less than 100 particles per cubic foot of air. As few as one particle landing on a critical area can kill a chip.
To give you an idea how clean this room is, walking alone produces 5 million particles every minute. So to avoid contamination from the inadvertently dusty staff, front-opening unified pods, or FOUPs, ferry packets of wafers through the intricate process of component construction. The key problem is miniaturizing the complex designs and imprinting them on the wafers.
So it's printing, actually. There's a term for printing.
It's done through a process known as photolithography. First, the wafer is coated with photosensitive chemicals, which harden when exposed to UV light. In sealed darkrooms, light is shone through an image of the design, then through a miniaturizing lens and onto the coated wafer. When the chemical is washed off, the design remains, just like a developed photographic image. But in order to pack all the components onto the wafer, they're built up layer by layer, like floors in a miniature skyscraper. So to complete the job, the Fups cycle the wafers up to 40 times, repeating the photo-etching process for each new layer. Some layers are cooked, some blasted with ionized plasma, some bathed in metals. Each different type of treatment changes the properties for that layer and slowly forms part of the jigsaw making up the chip's design. The finished sheets of silicon wafer carry up to 1,000 individual microchips and over 4,000 billion circuit elements. All that remains is to slice and dice, and the journey from sand to circuit board is complete.
Okay, we stop here. Can anyone tell me what's this circular thing?
Wafer.
Very good. That's called wafer. So it contains how many chips in there?
4,000 billion.
Many.
You mentioned.
4,000.
Let's sit down. Finish.
4,000 billion.
4,000 billion. No, how many
1,000.
chips?
10,000
billion.
1,000. So 1,000, about 1,000 chips. Remember how many degrees cook the silicon?
4,000.
No.
100.
Very close. 1,400.
50.
20.
Very good. 1,420. Exactly right. So we cook the silicon, then we make the block. It's very heavy, then cut it, slice it into a circular shape. Then they got a term to put the circuitry on top of that layer. They have a term for that.
Photo factory.
No, very close. So if someone said photo, Brian and Kendrick, I'll give point for that. But it's not photo. It's photo something.
Wait.
So let's check. So the word is called,
Wait.
under the dictionary, it's under photo. See, you can pronounce it.
Photolithography.
Very good. Photolithography.
Photolithograph.
Something like photograph. Okay.
Ah,
The verb and the noun, guys.
Photolithographer.
Photolithography.
Very close. So this helps us to put the layers into there. Is it clear now? Okay, we'll stop here. If you haven't had said and putting the video, now back to what we learned last time now. Under the CPU, headset down, and also don't touch anything. See, remember. We got something called register. Name the register for me. Cedric, what you doing? Name the register. No, what spelling? Name some of the register.
Accumulator.
Very good. Accumulator.
Status register.
One by
Memory
one.
disk.
Status
Please,
register.
one by one.
Status register.
Status register. One only. I will select the person then. I don't want people yelling out. So see how many. If you cannot, let's say you do not need to refer to the book. See, you can do that, okay? So I ask one by one to answer this. So up to now, we got the points here. Let's say. So choose the next one. Yo, give me a register. Instruction register. Very good. Next, study. Program counter. Good. Next, Brian. IAN. Any register? Okay, the next part.
Memory address register.
Very good. Next. Anyone? Okay, yes, hold it. interesting. Actually, in some books say index. In some other book, they don't call it index.
They call what?
What they call?
I don't know.
Okay. The other one, anything you want to add? Register. BR,
點解啊
the chosen.
？Status register。
Mentioned it. Donald?
Processor register.
Processor register, do we have that?
Yeah,
你炒埋機咧。
of course.
I don't think we mentioned it. Okay, last one, Kendrick.
General purpose register.
So all those are called general purpose. Sector, anything?
Instruction.
We do not call it hardware register.
I know.
Yes, Danny.
Base register.
What?
Base register.
Base register?
Cash
Memory
register.
data register.
Cash register.
Base.
Oh, I understand what you say.
Base.
Cash. That one's cash. Okay, thank you.
Cash register.
Okay, now, what I want you to do, I got a reading for you, is underneath calendar. It's reading number 2 is called computer register.
係已經有安排。
I got the vocab for you to go through and the reading.
I go out Christina.
Okay?
做居士啊？
I need to get.
Okay, get a headset if you want.
好係成
So remember how to spell all those registers. Those are needed for the test. And we are planning to have it very soon.
CPU 係個你擺落去。
Yes, I put it there. What do you say? GPR is meaning every piece of this. Yes, all those. We do not have that. Those are. Just read it. Do not need to do the feedback. We'll do the feedback later on. I have something more for you. So feedback's for homework. Question? You try to I think it's better than that. Yes? This one, please. You got 2 pro sector finished. Quite quick and handy.
好慢，我做咗2次喎，23.72嘢。
加得好快，
佢未講完，我已經打完。
打錯字啦，
佢打佢未講完，我已經打完。
就懶咗點解？我做多次。
instruction address 佢講到 address 已經打完。唔緊要啊，你冇有次佢有咩打到快到已經錯晒嘅。咩錯晒啊？我慢慢打。
Instruction
Maybe the headset or what?
address.
Or the computer itself. The code. Okay, once you finish read the article, I'll give you 5 minutes for that. Then we'll carry on fetch cycle. Only 9 words. Okay, I got 7 of you finished. No need to tell you feedback. Feedback we'll do it later. But I want you to go through the reading first. Then we'll carry on to the instruction sign again. Do the reading. Fine. Make sure you remember how to spell each one of them. Very important. go through the reading. If you don't have time, I don't allow you to carry out 3 more minutes.
唔使有 feedback 咁細。
Just go for reading. If you go on, you can do it, but it's not compulsory for the moment, but you have to do it later. You just focus on typing. You've got 24 typing. Correct, exactly. Just do the reading. Okay, 9 people submitted. Okay, I'll give point for everyone. For those did twice, I'll give extra 1 point. Because they,
咁如果做咗10次，你有得
well, because they quickly finish. After that, I'll ask a question about the reading. Reading is very short. Just mention the fetch, decode, and execute cycle. That's the most important thing. We're going to talk about that later on. Make sure you understand what's fetch, decode, and execute. The 3 terms, very important.
What?
Fetch,
fetch decode execute。
decode, execute. We'll talk about that. Okay, don't only look at that. 2 more minutes. Please understand how the fetch being done. What's the decode? And what's the execute? Yes. Okay. So make sure you understand what that 3 steps. What are those working for? We'll wait this slow. Okay. So very important. I want to register. Then we come to fetch, decode, and execute. Okay, last minute. Finish reading it. I'm going to ask a question again. Also, I have 3 persons, I think 3, haven't submitted the last reading. Which one? The first one, computer component. You submitted on my check. I marked it already. You can check from that.
Okay.
We close the things here. Okay, ready?
Wow.
Forget about the type, the feedback. We do not have much time for this. I want to carry on something else, please. Okay. Okay, can I take over your screen then? Ready? I'm going to take over now.
How come I can't get a star?
真的。
It's for people to like your work and you get a star.
Hey, like my work.
我有。
Okay, I'm going to take over now. Thank you.
Take all the
Now,
會打。
thank you. Okay, I'll release. Please submit. So make sure you're not losing the thing. I'll allow you to submit them. Okay, just press submit, please. Ready? Ready? Okay, take over now. Now, the 3 cycle, fetch. Can anyone tell me what's a fetch meaning? Yes, Brian?
taking
To take the information from the user to the main register and fetch information.
Okay, can you use one English word to elaborate this?
get take
Get.
Take.
Can anyone use other word?
take
Retrieve, very good. Any other word?
take
Take, any other word?
Correct.
Very good. Who said read? Very good. So actually it's read, fetch, retrieve, take, get, whatever. Now, the decode. Before the instruction be decoded, the instruction is saved inside certain register. What is the register being saved? The instruction. Instruction register. Thank you, Brian. Then we decode. Once decode, then we need to get the instruction from memory. Before we get to the memory, we need to place the memory address to a register. What is that register?
Memory address register.
What is it?
Memory data.
Brian got it correct. Memory address register. Got it? So you get to the data. Thank you, Brian. Then you need to get the contents of the memory. So where this memory content will be sent to, which register?
Memory data register.
Memory data register. Thank you, Brian. Now, we're going to look at the fetch cycle. Two Brian are quite bright today. So we're going to look at the subject ICT. I got something for you underneath the system. It's called, underneath the CPU, it is called fetch cycle, this execution cycle simulator. Let's watch it together then. It's quite clumsy, the word. I'll take over the screen. Okay, watch it together.
I don't.
Is it on your screen?
No, you uncheck.
Wait for that. I'll have to take the screen.
Wait.
Okay, now, just watch this carefully. We got the register here. Program counter. What's program counter is for? What's the usage then?
to send instruction
Not send instruction. What's the program counter function?
for
To
Count the program.
So what's this use? Not counting program, counting something.
tell them where to fetch.
Where to fetch? So telling the
The memory address of the.
memory address. Very good. So both Donald and Patrick. So now
I did something.
we got. I checked already. Now from here, please watch it carefully. Move R1 to Tom side 13. This is the address, okay? The hash. Now
13, I think.
R1
I want it.
is the register number 1. So temporary storing the value. So let's begin then. So one click. The 1 is given to MAR. The MAR locate. You see the bus name. So carry the thing back now.
Okay.
So instruction number 1. Instruction number 1 is inside the instruction register now. Now, need to decode. So they decode it. Finish. So they send the move R1 to the address. To the address 13. Is it down there a little bit? No. Let's see. What's next? It's moving now.
The control unit.
Now, moving R2 6 to R2, the 13 is up there now. So each cycle they have to decode, then they execute. So they got what they are now.
I still don't understand.
Still don't understand.
Now they decode. They got the instruction. Number 2. Number 2.
咁即係個 number two 嘅 code 就係 move out to
Yes. So they first fetch the instruction, the second one, to the instruction register. Move R2 6. So now they execute. The execution, now they decode and execute.
即係
Now they
要
execute now. This is that. So you see the, let's say where it's go. This instruction was analyzed to move the instruction using, let's say the 6 will come up. So you see the bus going on. Now they're on the data bus, so carrying the value.
就 R 2入邊落，你點會打死？
哇哇
24 not 6。
我想知啊。
哦。
哦
Now
，6
we move
係
back.
4哦。
Adding R1, R2. So they need to get the instruction
不
now.
停你撳你撳佢去做。
Now they're getting instruction of 3.
點解 PC 會俾有4嘅？
The next step.
幾多個 instruction 㗎？
The next step.
句做乜嘢啊嘛？
The next step.
然之後
Now they got the instruction 3.
就 add R1 R2。
Add R1, R2.
即係37。
So now they decoded.
再搞
They
再搞
decoded. Now they execute.
點解會 AM？
咩 ALU 啊？
啱即係兩 logic unit。
Now they do the
加
calculation.
埋一齊。
Now they do the calculation.
跟住開波啦。
37.
哇！真係
Then they stop. Okay, this is a simulator. I want you to do the other one. The other one is a little bit tricky. Let's see. The other one is called Simple Assembly Language Computer Simulator. So very complicated. They got coding. So how it runs, I want to show you how. So this is decoding. You can try before the bell end. First one, read, meaning input a value to a computer. Store to 08, meaning store the value to memory address number 8. Read a number again. Add 08. Print. Display the value. Read again. So we just stop here. 04. Okay?
What is
Print.
the next one?
Branches mean comparison.
Wow.
To 00 meaning continuous. Now we just stop here. Print. Okay? So how it runs? You click on that connection. It's underneath the computer execution cycle simulator. Then you click on here, start. So how it runs, first, read. So you have to click the read, put it here. Then, what's the second one? Store.
咩啊？
08啊。
So store 08, you press 08 here. Okay? Then, what's next?
再 read
Read again. So press read.
And
Then,
add
add
08
唔係 0X。
08
so add 08 again. Then print.
跟住 print
都係佢頭先講。
Okay, once you're ready, you press compile. Compile means changing to a language that computer understands. Now they're asking you input a number. Say 7. Oh, I have to put run first. Run. Starting now. 7.
咁先問
Then
搞嘢嘅。
pressing enter.
點解我瞓覺？
係咪
So you got 7.
你第7個冇
Input again.
1
1. You want me to put 1?
咁就變8。
係嘛？唔係
What's
兩
next?
先
A step.
知
Okay, now stepwise. Input another number. 1. Enter.
應該係吧？
Step.
入去8。
Step. So it print out. Is it clear?
What is the outstream? Oh.
I don't get
Okay,
it.
you got the 8 here.
I don't get it.
哦。
So you have to program the computer to run. Okay, I'll release you now. See, you can continue with that. And tonight, I got you a quiz. I will send you an email. You're going to make 5 questions. Good, I'll check now. It's under CPU? Sunny? Okay. Also, I created the register for the question. So please submit 5 questions for register. Can you find it? Just simulate a program. Read. So that's how computer works. Very stupid. They have to work step by step. Even adding 2 numbers. Yes. Under. Yes. That's the first one. Yep. The first one. Next term. But I want to put that. Oh, can you do the simulation? Can we check the work? You need to? Yes? Sunny, have you uploaded the quiz? You create a file, create a quiz, have you uploaded? Let's see it now. I have to double check. Yeah, I'll be right back. Wow. Yes. Yeah, type a number. Read meaning you enter a number. Then press enter. Need to, otherwise you can do not know where to store. So you put address number. The 01 you cannot use. The 01 is already a program. So you must use those free space. Okay, anyone successful got the output?
Yes, me, thank you.
Good. Can I say that? You shut it down already.
Yeah.
Never mind. You got it?
Yes, sir.
I got it.
Run it. Okay.
I got it.
Right. Okay, I'll see it. Okay, good. Very good, open.
I got it.
Very good. Okay, good, Brian. Done? Very good. Stanley, Section, Yo-Yo, and Sunny are a little bit quiet today. So make sure you try the simulator before you go. Successful. Okay? So then we watch. I'll see you around. So tonight, create 5 questions underneath register. Okay, got it? And also do the reading, say homework, put in the feedback. That's all I require today. Okay, thank you. See you all.
It's awkward.